too hard.
Oh, I got it.
I know, but eliminate r right away. Yes. You can work with this, and you must use the product rule then. But it's complicated. Well, you can do it, but you're not going to understand it. It's way too complicated. What'd you get? What's 1 over 4 pi? I didn't use a calculator. Is that? Yeah, but that may be the same answer. I don't know. Okay, now you don't have to eliminate r, and we can see that solution if you would like to. I have one here. He gets the right answer, and I've seen sometimes on the exam where you cannot eliminate one of the variables, and you must do the product rule. But the thing is it's easier if you eliminate a variable. And I know right here that r is equal to 2h, and this tells me what I want to relate. Had I had r and v there, then I would have solved for h in terms of r and eliminated the h. So when I do this, and I could see where the problems were, it's 1, which was good. I'm glad I just let you work on it. This is what? 2h squared times h. You need to simplify that. If you take the derivative as written, you must use the product rule. And if you don't do that, you get 3 divided by pi, which I saw numerous times. So it's pi. I've got a 3 there, and this is 4h to the what? Third. So v equals 4 pi over 3 h cubed. I want to keep my constants together. Yes, but there were other people that took the derivatives separately and multiplied them, and then you get 3 over pi, which that's not correct. So now, you can keep the r in there, and like I said, if you want to see it done with the r in there, it might be a good thing, actually. The 3's will cancel, so I get 4 pi h squared dh dt. Now, what's dv dt? 16. So 16 equals 4 pi. H was 4. So it's times 16 dh dt. What happens to the 16th? Divide both sides by 16. So 1 equals 4 pi times dh dt. And then you divide by 4 pi. Is that the same answer you got, Eric? Okay, but it can go faster, harder as it might be to believe, without a calculator. Yeah. Now, the next problem, the only way you get better at it is to do it without the calculator. Is that okay? Okay. Are we ready for the next one? Now, I'm sorry, the picture is deceiving. We've done this problem before, but we are in the helicopter, and we're looking down, and here is the shoreline. And do I even have that number in the wrong place? No, the number's in the right place. The lighthouse is coming out at you. This should just be a line here of 1 kilometer. I should fix my picture. And it says it's rotating at 2 revolutions per minute. That makes that tricky. At least I think it makes it tricky. What is that? Well, it's not quite the angle. It has to be radians per minute if we're talking about how the angle changes. So 1 revolution equals how many pi? 2. Whoops, I did it upside down. And how did I catch that? Because it wasn't, the revolutions was not going to cancel. And this is 2 pi. So this is going to be equal to 4, that's right, dimensional analysis. 1 revolution is equal to 2 pi radians. And so this is 4 pi radians. We don't say the word radians. I don't know why we don't, but anyway, per minute, which is the change in the angle per time. And you've seen those old movies, but some aren't so old, where people are trying to escape and they have the light going down the fence in the Prisoner of War movies. There was one recently. I don't remember which one that was. And you can see the light going down the fence line, and that's actually what they did in East Berlin. Many people died trying to cross the wall in East Berlin. I know, that's all history to you. Berlin is now a free city. But when I was growing up, it was not. And I would read all the time about people trying to cross that wall. There's a lot of stories about it. But the light would go down there, and of course, it travels. At any moment, you're taking a picture like this, or like this, or like this. And then it rotates around, and it goes out to sea, and then the light comes back here. You've been to Split Rock Lighthouse? And that's what it does. It rotates around. So we're going to take a picture from our helicopter looking down on this when this distance is 1/2 of a kilometer. I want to know what? I need to know something. How fast is the beam moving along the shoreline? Well, this is the length on the shoreline. What do you want to call it? L. I don't want to call it X. That's okay. So dl dt is what I want to find when this distance from here, and I know it's wordy, but it's the way it's written in the book. It says when the light passes the point 1/2 kilometer from the point opposite the lighthouse. Here's the point opposite the lighthouse. So it's going to be 1/2 kilometer from that. That's half the battle on the exam, reading it. So L equals 1/2. Sometimes when I look at those questions, because when I look at them fresh every year, it's the same as you, and I look at them like, how are they going to read all this? It scares me even. Okay. Now, what do we want to relate? L and theta. I don't want Pythagorean theorem because I don't have anything about this side at all. Okay, guys? Are you ready? What's the relationship between L and theta? Ari, what's the relationship? Now, I've got 3 trig functions. I got 6 trig functions I could use. But I want one that you use L and the one that I know in theta. So the tangent of theta is equal to what? L over 1. Just so that people could see it's the tangent. So now, let's take the derivative of that. Do you guys remember this one? No, that's inverse tangent. Secant squared. Remember the derivative of tangent secant squared times what? Now what? The derivative of the inside function. And if you don't have a d theta dt, you're in trouble, which is equal to dl dt. A double negative? Okay. Now, the secant of my angle is what I have to figure out. What is secant? Okay, it has to do with the cosine. So to do the cosine, they need the hypotenuse. I don't want to deal with fractions, do you? All these triangles are similar. If I take this triangle out here and I double the sides, so that becomes 2, and this becomes 1, what's this side? Square root of 2 squared plus 1 squared is 5. Now, I can find the secant of this angle, but can't I do the secant of this angle here? It's not a 60-90. Because if one leg is half the hypotenuse, you were thinking this is 2 and this is 1, then it'd be a 30-60-90. But you got to get them in the right place. Now, what's the cosine of this angle? It looks like a dot there, but it's 1 over the square root of 5. Oh, cosine. Sorry. I did sine. 2 over the square root of 5, so what's the secant? Square root of 5 over 2. Do I have to go back to the original triangle? No, they're similar. So it's 5 over the square over 2. Square root of 5 over 2 squared. You're not supposed to have fun in class? What's d theta dt? Forgot that. 4 pi, and I want to find dl dt. Did I make a mistake? Pardon? It's not. We're up in the helicopter looking down. It's opposite. It's a secant. So it's this one over this one. Okay. The tangent of this angle is opposite over adjacent. That says it's 1 kilometer. You're 1 kilometer from shore. It's not drawn to scale. I never draw to scale. I can't hear you. This is 1. That's 1. It's given. It's 1 kilometer offshore. No. You gotta listen. We are looking down at this. This is not the height of the lighthouse. It says the lighthouse is 1 kilometer off the shore. Huh? Yeah, and I apologize for the picture. And this light is coming down the shoreline, but you're up in the helicopter looking down at this. And then next moment you see it there. So what is that? 5 force? Yeah. So it's 5 pi. The tangent of this angle is opposite over adjacent. So tangent of theta is equal to L. Then I took the derivative. Well, try the next one. The sailboat has a motor. Okay? Try that one. I haven't dropped grades yet. And I haven't done. You don't want to hear about the Sailor project. I have it safe in my hands now, but my renter threw it out. Threw them all out. Oh, I'm sure I have it, but I'll double check. I know. That's why I thought about leaving them. Okay. Eric, what'd you get for your find? At what rate is the angle? And you know that it's rotating at what? Oh, no, I don't know that. The both. So dx dt is equal to 20. Well, it all depends. They aren't going to worry about signs here. But what's the relationship? This is 250, isn't it? Is that right? So the tangent of theta, then you take the derivative. Secant squared of theta, d theta dt, 1 over 250 dx dt. And I know something. Do I know dx dt? This is 20. I want to find this. Hey, what did you guys get over there? Now, at the snapshot. This is 250. This is 250. What's the hypotenuse? It's 250 times the square root of 2 because this is what kind of triangle? Pythagorean. 45, 45. You're right. You did. So what's the secant of my angle? See, cosine is 1 over the square root of 2. So secant is the square root of 2 over 1 times d theta dt equals 20 over 250. So 2 times d theta dt is equal to 2 over 25. Okay, those of you who got 10, I don't know how you got 10. How'd you get 10? Because this length is 250. When you take the derivative of, it's 1 over 250 times x. That 250 doesn't go away. It's still there. The derivative of this, got to use the chain rule. Did you guys get it? Okay. How about any questions on the algebra assignment that I'm going to come around and mark off that you did it? 1/25. Because the tangent of this angle is x over 250. Then you have to do the chain rule. Oh, okay. You still have to do the chain rule. Okay, 1 through 10 on the algebra sheet. Ooh, time flies when you're going. Okay. I need a sheet. Oh, well, no, maybe not. Now, to do logs, I don't know if I have a copy. Hey, guys, the pink sheet. What number is the logs? Yeah, there was a lot. 9. You're better off up here. It's the log of what? Okay, you guys. That was what was on the exam last year was logarithms. That was on, so I don't know if it was a double bubble or if it was a common problem. I can't remember. I got to grade it 2 years in a row, basically. Okay, you guys? Properties of logs. There's only 3 things you have to know. The log of x to the r is, that's right. And remember, these are exponents. So the log of a times b equals the ln of a plus the log of b. So what's the log of A divided by B? Because we're dividing, we have the same basis. What do you do with the exponent? You subtract it. Ask. Okay. Now, if I want to combine my logs into a single log, I can't have that 3 there. So this is the log of x to the third. No, you're almost there. Okay, Eric, how do we do this? That reduces. No, but you, unless I didn't hear the x in the denominator, but you did reduce. So if you reduce, you have to reduce correctly. So this is x cubed over 3x times 12x squared. No, it isn't. This is, it's 12x to the fifth over 3x to the first. So if this were for a response, you're better off with this answer than the other answer here by simplifying wrong. Well, if it's multiple choice, you have to simplify. Now, they're not going to ask you a question like this. They're going to ask you to solve an equation with exponentials and logarithms. So you got to be careful with it. Can you take this r and distribute it inside the x? No. Well, that I saw as a common mistake in the exam. Partly because it was a -1 and not just a number. It's not time to go. You have 10 minutes. Okay, well, how about other ones? Did you get number 10? I do too have a copy. Okay, some of you have problems with the substitution here. I want f of x plus h. Okay, so do that. So in place of x, I'm going to put in x plus h. So what is f of x plus h? Okay, some people want to put the h here because it doesn't belong there. It's x plus h goes there. Partly because you don't like the way it looks. What is f of x? Now we're going to get a complex fraction. 1 over x plus h plus 2 minus 1 over x plus 2 all over h. And you guys don't like fractions. So let's make this easy. Okay, David? What could I multiply by in both the numerator of my fraction and the denominator to make the fractions go away? When in doubt, multiply the denominators together. If I were to teach fractions in the lower grades, wherever that's being taught, I would absolutely not do common multiples. I mean, lowest common divisor. I would say just multiply them together, we'll reduce later. But because this always works, I'm going to pick a number that I can multiply by so that when I distribute this, they will cancel. Now, I've unbalanced my expression. This is not an equation. It's an expression. This is not equal to what I started with. So to make it equal, the denominator has to be multiplied by the same factor. Some of you like to put, hang on. Some of you like to put, some of you like to put these factors up here. And you can't, it just makes life worse, that's all. Okay, what happens when you multiply that out? What happens to the x plus h plus 2 with this x plus h plus 2? They'll cancel, right? And what are you left with? X plus 2. Notice my use of parentheses. Not necessary in the first one, but you guys don't sometimes know when it is. What's going to happen to this x plus 2 with this x plus 2? They will cancel, but I'll be still left with that. And if I don't have parentheses, I'm going to make a mistake. Well, only if you know it. I don't know if you know it. Take the product of the two denominators in the numerator and in the denominator of the big fraction. Well, you guys, if I have this, because some of you want to cancel the x plus 2 and the x plus h plus 2. Hey, guys, listen up. Can I cancel it here? And if I can, I don't really know what you get, to tell you the truth. So I can't do that. Math always tells me what to do if I'm willing to read it. I can't cancel, but what can I do? It's like begging me to do this. Let's distribute that negative and simplify that. So it's x plus 2. Now, if you don't have the parentheses there, you're going to have a sign error. Minus x minus h minus 2. Now, by the way, what is this expression? Okay, guys, what is this? It's almost a derivative. It needs a limit. So it's an average rate of change rather than an instantaneous rate of change. And if you remember, if I were to take a limit and let h go to 0, I would get 0 over 0. Guys, I'm going to ask you to be quiet. And when you get 0 over 0, that means you had some factors, if they're polynomials, that cancel. So I got to find out what would be canceling out. It's just a math trick. Right. But if I don't have this minus sign here and with the parentheses, I'm going to mess up the sign. And I promise you, these will always cancel out. Always. So if they don't, you made a sign error. So I'm left with a negative h. My algebra kids want to throw that negative out. And that's the 0 over 0. The h's will reduce. You call it canceling. I'm dividing by h in the numerator, leaving a 1 and h in the denominator. So there's your answer. Negative 1 over this thing. If you want the derivative, you would take the limit. Now, what I'd recognize is if it is a derivative, I'd rather do it the easy way than the hard way. Unless they tell me to do it the hard way. Your homework tonight is to continue working on 4-1 and do the next 5 on the pink sheet. Now, before you go, I want to check your pink sheet. I know I've seen yours. You don't have yours. I'm just checking you off. Oh, wait. We don't have to record this.